Hi everyone, today we are going to see some basic concepts about eigenvalues and eigenvectors. First of all, eigenvalues and eigenvectors are used in diagonalization of matrices. Diagonalization of matrices are important when we are solving a system of linear equations. For that, eigenvalues and eigenvectors are very important plays a major role in diagonalizing a matrix. So first we find the eigenvalues and eigenvector of a linear transformation. A linear transformation, consider a transformation on R power n. A transformation is said to be a linear transformation if t of ax plus by equal to a into t of x plus b into t of y. So for that linear transformation on R power n, there exists a non-zero vector v in R power n such that if t of e gives lambda times, that is constant times or scalar times v, then lambda is said to be an eigenvalue of the transformation t, and v corresponding vector v is said to be an eigenvector of capital T with respect to lambda. So for that we consider a linear transformation which is a reflection about the line y equal to x by 2, and consider two vectors b1 and b2, where b is 2 by 1 column vector and b2 is minus 1 by 2. So while considering a reflection about x by 2, since b1 lies on the line x by 2, so its transformation gives the same value, that is t of b1 equal plus b equal to b1. And since b2 lies in the second quadrant, so if its reflection about the line x by 2 gives the same value in fourth quadrant. So its values becomes plus 1 my minus 1 by minus 1 comma 2 vector becomes plus 1 by 2 plus 1 comma minus 2. So that this reflection gives t of b2 equal to minus b2. So here b1 equal to t of b1. So that's why here lambda is equal to 1. So for the corresponding vector b1, lambda, the eigenvalue is 1, and similarly for the vector b2, that is minus 1 comma 2, the eigenvalue is constant minus 1. So next we find likewise we define eigenvalues and eigenvectors on a matrix. So for a consider a n by n matrix A, and similarly find a non-zero vector v in R power n. So if v is a eigenvector of A, then AV gives some constant times v. Okay. Then lambda is said to be an eigenvalue of the matrix A, and v is said to be a corresponding eigenvector to lambda. Yes. Here consider a 3 by 3 matrix which is denoted by A. That A matrix is a 5 2 1 minus 2 minus 1 and 2 2 minus 4. And consider a vector B, which is a non-zero vector. So since not all entries are, a vector is said to be a non-zero vector when its all entries are non-zero. Some non-zero vector means some entries must be not equal to 0. Okay. So here I take the vector 1 minus 1 plus 1, which is a non-zero vector, while multiplying with A, which gives the values 4 times of 1 minus 1 plus 1. So here that vector 1 minus 1 plus 1 when multiplied by A gives some constant multiplication of the same vector. That is 4 times of 1 minus 1 plus 1. So 4 is said to be an eigenvalue of the matrix A corresponding to the eigenvector 1 minus 1 and plus 1. Since there is a relationship between a linear transformation and its corresponding matrix, so while finding the eigenvalues and the eigenvectors of a linear transformation, it is enough to find the eigenvalues and eigenvectors of its corresponding matrix. So there is a general method to find the eigenvalues and eigenvector for a n by n matrix, and this is the formula. If A is an n by n matrix, then its eigenvalues and eigenvectors satisfies the equation A minus lambda in, where in is the identity n by n matrix, into x equal to 0. So let me consider an example in which we have to show that we will show that 3 is an eigenvalue of the matrix B. If it is an eigenvalue, then we find the eigenvectors of corresponding eigenvalue. So consider matrix B. So we have to from this formula we have to find B minus 3i, and I find that value in reduced row echelon format. So it gives 0 1 minus 1 0 0 and 0 0 0 0. So while multiplying this with x, we get the solution as x2 minus x3 which is equal to 0. So solving that we get x2 equal to x3. So here if we fix x3 as 1 and x2, then x2 becomes 1 and x1 is we can't find the value of x1, so we fix x1 as a free variable. So by finding these values, we found two vectors. One is for x1, which gives the values 1 0 0, and for the second relation, that is x2 equal to x3, we get the vector as 0 1 1. So multiplying these two vectors with b minus lambda 3i, we get the multiplying these two vectors with b, that is bx, which gives the values 3 into x. Okay, so that these two vectors becomes an eigenvectors corresponding to the eigenvalue 3.